Imagine for a moment that you are standing in a strange and wild scene. A massive T-Rex, with its large head and sharp knife-like teeth, is striding through the snow-covered lands of the Arctic.
You might think this is a scene from some science fiction movie, right? But have you ever wondered if, during prehistoric times, this terrifying dinosaur could have actually survived in such a cold, harsh environment? Perhaps this story sounds unbelievable, but in reality, many scientists have proposed the hypothesis that the T-Rex could have lived in the Arctic during the Cretaceous period. And today, we're going to explore this fascinating question. Could the T-Rex have lived in the Arctic? We won't just talk about the harsh conditions this dinosaur might have faced, but also look at whether there is scientific evidence to support this hypothesis. The Arctic, during the time of the T-Rex, was not like the frozen landscape we see today. Back then, this area had a climate that wasn't as cold as it is now, but it was still a very different environment compared to the tropical forests we often associate with dinosaurs. However, could species like the T-Rex have survived through the long, cold winters of the Arctic, with its massive body and high food demands? With its overwhelming strength and powerful hunting abilities, how might the T-Rex have adapted to survive in such a harsh environment? Or was the Arctic simply too cold for it, making survival impossible? Today, we'll analyze these environmental factors, climate conditions, and scientific evidence to see if there is any basis for the question, could the T-Rex have lived in the Arctic? Get ready for a journey into this prehistoric mystery. To fully understand whether the T-Rex could have lived in the Arctic, we first need to take a closer look at what the environment was like during the Cretaceous period. Specifically, we're talking about the Arctic region, where we now see vast, icy landscapes. But did the Arctic of the past really look like that? Well, the answer is no. The Arctic during the Cretaceous wasn't the frozen wasteland we picture today. In fact, scientists have found that the climate of the Arctic was much warmer during the late Cretaceous than it is now, with temperatures averaging higher than today's freezing levels. While it wasn't exactly a tropical paradise, it certainly wasn't the icy tundra we think of today. During the Cretaceous, the Earth was in the middle of a warm period. This was partly due to higher levels of atmospheric CO2, which contributed to a greenhouse effect that kept the planet warmer overall. Even the poles, including the Arctic, experienced milder temperatures, much like today's temperate climates. In fact, researchers believe that the Arctic during this time had seasonal warmth, with temperatures averaging between 5 to 10 degrees, 41 to 50 degrees. These temperatures would have allowed plants and a variety of other species, including dinosaurs, to thrive. The idea that the Arctic was more temperate rather than frozen is supported by fossil evidence. Paleontologists have discovered fossils of plants and animals in Arctic regions that indicate there were once lush forests, swamps, and freshwater lakes. This warmer climate would have supported a much more diverse range of life than the frozen tundras of today. So, the Arctic wasn't the inhospitable region it is now, but rather a place where life could still flourish, including large herbivores that could sustain carnivores like the T-Rex. But here's where things get even more intriguing. The T-Rex, known for its massive size and insatiable appetite, would have needed a substantial food source to survive. Could the Arctic's warmer Cretaceous climate have provided such resources? Fossil evidence suggests that large herbivorous dinosaurs like hadrosaurs, duck-billed dinosaurs, and ceratopsians, horned dinosaurs, lived in the northern regions. This means the Arctic, while far from tropical, was still home to plenty of prey for a carnivorous giant like the T-Rex. With all of this in mind, it seems possible that the T-Rex could have found enough food in a warmer Arctic environment, especially if its prey, like hadrosaurs and other herbivores, thrived there as well. However, just because the climate may have been conducive to life
doesn't necessarily mean the T-Rex could have adapted to the conditions. Could it have survived the seasonal extremes of the Arctic? Would its body, built for heat and speed, have been able to handle the challenges of the far north? Let's dive deeper into these questions and examine how the T-Rex might have adapted to life in the Arctic, and what role the temperature and seasonal changes could have played in its survival. Now that we know the climate in the Arctic during the Cretaceous was significantly warmer than it is today, the next question we need to answer is whether dinosaurs actually lived there. And if they did the T-Rex ever roam these northern territories? Paleontologists have found surprising evidence suggesting that the Arctic was not only habitable, but was actually home to a variety of dinosaur species. Fossils discovered in the northern regions, such as Alaska, Canada, and Siberia, show that during the Cretaceous, these areas supported diverse ecosystems, including large herbivores and smaller carnivores. Some of these fossils even belong to dinosaur species that were once thought to be exclusively tropical or temperate, proving that the Arctic was far more than a cold, barren landscape. One of the key pieces of evidence comes from the discovery of fossilized remains of a variety of dinosaurs, including theropods and herbivores. These fossils have been found in ancient riverbeds, lake beds, and even forests that once flourished in the Arctic. For example, fossilized bones of large plant-eating dinosaurs, such as hadrosaurs and ceratopsians, have been unearthed in the Arctic, indicating that these herbivores could survive in such regions. If there were herbivores, that means there were likely predators as well, possibly including the T-Rex. Additionally, the discovery of a new species of theropod called Troodon in the Arctic further supports the idea that carnivorous dinosaurs could thrive in these northern climates. Troodon was a smaller, more nimble predator compared to the massive T-Rex, but its presence in the Arctic suggests that the region was indeed a suitable environment for at least some types of theropods. Paleontologists speculate that Troodon may have been a hunter of smaller prey, such as young dinosaurs, and could have even lived alongside larger carnivores like the T-Rex. But what about the direct evidence for the T-Rex? While no fossils of Tyrannosaurus rex have been definitively found in the Arctic, some researchers believe that it is possible the T-Rex did roam the region. It's important to remember that the T-Rex was not confined to a specific habitat. It was a versatile predator that could adapt to different environments. Its size, speed, and ability to hunt large prey would have made it a formidable force in many ecosystems. There's also the argument that, while the T-Rex may not have directly left fossils in the Arctic, its close relatives could have ventured there. Fossils of relatives of the T-Rex, such as Alberta rex and Gorgosaurus, have been found in similar northern latitudes. These smaller relatives shared many of the same traits as the T-Rex, such as their predatory nature and large size, making it likely that the T-Rex could have ventured into the Arctic as well. In summary, while the T-Rex may not have left direct evidence of its presence in the Arctic, the discovery of its relatives and other large theropods in northern regions suggests that it's not entirely out of the question. The evidence of various dinosaur species living in the Arctic suggests that the northern latitudes were indeed a thriving habitat for prehistoric life. But how did these creatures survive in such extreme conditions? Let's explore how these dinosaurs may have adapted to the challenges of life in the Arctic during the Cretaceous period. Now that we know dinosaurs did indeed live in the Arctic during the Cretaceous, the next logical question is, how did they adapt to such extreme conditions? Today, we think of the Arctic as a frigid, barren wasteland. But during the age of the dinosaurs, the region was far different. With a warmer climate and lush ecosystems, the Arctic supported a range of dinosaurs and other prehistoric animals. One key factor that helped dinosaurs survive in these northern regions was the warmer climate. During the Cretaceous, the Earth's climate was generally warmer than it is today, with higher temperatures and more even seasonal variation. This warmer global temperature meant that even the Arctic had a much milder climate, with temperatures that rarely dropped below freezing. Paleontologists have found evidence that ancient Arctic forests, full of conifers, ferns, and flowering plants, once thrived in the region. This plant life was essential for herbivores, which relied on these abundant food sources to survive. But how did the carnivores, such as theropods, adapt to living in these environments? First of all, it's important to note that the Arctic of the Cretaceous was not an icy polar desert like it is today. Instead, it was a region teeming with life, with lush forests and rivers, much like the temperate zones that we have today. The presence of large herbivores meant that carnivorous dinosaurs, like the theropods, would have had an ample food supply. In addition, paleontologists believe that certain dinosaurs living in the Arctic may have developed specific traits to cope with the environmental conditions. One of these adaptations was the development of a thick, insulating coat of feathers or scales. Similar to modern-day animals in cold climates, such as penguins or polar bears, some dinosaurs may have had insulation to help regulate body temperature. For example, Sinornithosaurus, a feathered theropod from China, had a fine coat of feathers, which would have been useful for thermal regulation. It's possible that other northern dinosaurs, including some smaller theropods, had similar feathering to help them stay warm during colder periods. Another adaptation likely involved the way these dinosaurs hunted and lived in the Arctic. Since the Arctic was far from the tropical jungles of the South, food might have been more scarce at certain times of the year, especially during the long polar nights. As a result, some dinosaurs may have developed strategies to cope with seasonal changes. Larger predators like the Troodon and Gorgosaurus may have been opportunistic hunters, preying on animals that were hibernating or weakened by the cold. In some cases, these carnivores may have survived by scavenging when hunting was difficult. Additionally, the longer days and short nights during the Arctic summer may have played a role in how these animals behaved. With continuous daylight, certain dinosaurs might have become more active during these periods, hunting and feeding extensively during the extended daylight hours. This behavior would have allowed them to build up energy reserves to survive the harsher winter months. The ability of Arctic dinosaurs to thrive in such a challenging environment showcases their remarkable adaptability. Their ability to survive in extreme conditions is a testament to how evolution allowed them to make the most out of their environments, no matter how far north they roamed. In the following sections, we will look more closely at specific dinosaur species that thrived in the Arctic, and how their adaptations helped them survive and dominate these northern landscapes. Stay tuned. While dinosaurs in the Arctic had to endure certain challenges, one factor that may have played a significant role in their survival was migration. Much like modern-day animals, it's possible that some species of dinosaurs migrated between different regions to cope with extreme seasonal changes. In the Arctic, the long days of the summer were followed by harsh, dark winters. During the warmer months, the region would experience nearly continuous daylight, giving herbivores a chance to feed and prepare for the long winter. Carnivores, on the other hand, could hunt extensively, taking advantage of the abundance of prey. However, as the winter set in, food would have become more difficult to find, especially in the dark months when vegetation died back and many animals became dormant or hibernated. This seasonal change likely led to some dinosaurs migrating in search of better feeding grounds. Much like modern-day animals, such as caribou or wildebeests, some dinosaurs might have traveled to more temperate areas during the harsh winter months. This migration would have allowed them to avoid the coldest, darkest parts of the year, ensuring that they had a stable food supply. For carnivores, this migration may have been essential for survival. Predators, like theropods, might have followed herds of herbivores southward, ensuring that they would always have enough food. Some researchers have speculated that certain species of theropods, like Troodon and Gorgosaurus, may have been migratory, following the movements of prey animals. The migration of herbivores would also be an important aspect of the ecosystem. In the Arctic, many of the large herbivores, like Hadrosaurus and Edmontosaurus, would have had to move in search of food as the seasons changed. These herbivores might have traveled to warmer regions, or they could have migrated to areas where the food supply was still abundant during the colder months. Additionally, paleontologists believe that some Arctic dinosaurs could have exhibited a behavior known as seasonal torpor. This is similar to hibernation, though not as extreme. During the colder months, certain species may have entered a state of reduced metabolic activity, allowing them to survive when food was scarce. This is not a confirmed adaptation for dinosaurs, but it's a possibility based on what we know about modern animals, such as bears and some reptiles, that engage in hibernation or torpor during harsh winters. Even if migration was not the sole solution to survival, it's clear that the Arctic dinosaurs had to be highly adaptable to their environment. The seasonal fluctuations in temperature and food availability meant that these dinosaurs had to be resilient in order to survive through both the long Arctic summers and the cold winters. In the next section, we'll dive deeper into the specific dinosaurs that lived in the Arctic and how they coped with these harsh seasonal changes. Stay with us as we explore more fascinating facts about these incredible creatures. One of the most significant challenges faced by dinosaurs in the Arctic was the extreme seasonal fluctuations. Unlike more temperate regions, the Arctic environment was subject to long, harsh winters and relatively short, cool summers. These drastic seasonal changes meant that dinosaurs in these regions had to develop unique strategies not just to survive, but to thrive during the colder months when food was scarce and the days were mostly dark. The most obvious seasonal challenge was the long Arctic winters. During this time, daylight would be scarce, with the sun remaining below the horizon for weeks or even months. This period of darkness could have made hunting or foraging extremely difficult for herbivores and carnivores alike. During these months, dinosaurs had to rely on energy reserves, such as stored fat, to survive. Many of the herbivores living in the Arctic likely consumed large amounts of plant material during the warmer months, storing nutrients for the months of darkness. Carnivorous dinosaurs, on the other hand, would have faced challenges in finding enough food to sustain themselves during these months. Without the long daylight hours to hunt, predators may have relied on scavenging or hunting during the brief daylight hours in the winter. Some researchers believe that these predators, such as the T-Rex, were able to adapt by increasing their hunting efficiency, becoming opportunistic feeders when they could find prey. This likely contributed to their status as apex predators in these harsh environments. The sudden changes in weather, particularly the transition from the long days of summer to the long nights of winter, would have also posed significant stress on the dinosaurs. The brief Arctic summers may have been warm enough for plant life to flourish, but the winters were marked by bitter cold and strong winds, creating a highly unpredictable environment. This extreme weather would have forced both herbivores and carnivores to adapt to the constant shifts in temperature and available resources. One key adaptation for Arctic dinosaurs was their ability to migrate, albeit over shorter distances compared to those species in temperate regions. Evidence suggests that some species, like the Edmontosaurus, may have migrated seasonally, moving between different parts of the Arctic region in search of food and more favorable conditions. These migrations would have been crucial for survival, especially as food supplies in one area dwindled due to the seasonal shifts in climate. Another important factor in the survival of dinosaurs in the Arctic was their ability to withstand the extreme weather conditions. Dinosaurs such as the Hadrosaurus and the Therizinosaurus likely had specialized adaptations to cope with the long, cold winters. Their feathers or fur-like coverings would have helped insulate them against the freezing temperatures, offering them warmth in the icy landscape. These adaptations would have been essential for their survival during the long periods of darkness and cold. These dinosaurs' ability to endure harsh seasonal changes was a testament to their resilience and adaptability. As we continue to explore the fascinating lives of these Arctic dinosaurs, we will delve deeper into how they interacted with each other and their environment to overcome the challenges posed by one of the Earth's most extreme habitats. The existence of dinosaurs in the Arctic has long been a topic of intense scientific debate. But with the discovery of various fossils and climate data, we are now starting to get a clearer picture of how these creatures lived in such extreme conditions. Fossils of Arctic dinosaurs have been found in regions such as Alaska, northern Canada, and parts of Siberia, providing valuable insights into their environment and how they adapted to survive in the cold, dark, and often inhospitable landscapes of the Arctic during the Mesozoic era. One of the most famous fossil discoveries that support the idea of Arctic dinosaurs comes from the discovery of a Tyrannosaurus rex fossil found in the northern parts of Alaska. This finding suggests that the T. rex did not just inhabit temperate or warmer regions, as was once thought, but that it also roamed the Arctic. This particular fossil is significant because it is evidence that the T. rex could have adapted to an environment with extreme seasonal changes, and it likely developed hunting strategies that were suited to the longer nights and cold temperatures of the Arctic winters. Additionally, numerous other dinosaur fossils have been found in the Arctic, including the Hadrosaurus and Edmontosaurus, which were herbivorous dinosaurs that roamed the region during the late Cretaceous period. These fossils provide us with important clues about the types of vegetation that existed in the Arctic at the time, as well as the diets of these plant-eating dinosaurs. The discovery of their fossils in these northern latitudes has shown that, despite the harsh environmental conditions, there was an abundance of plant life that supported herbivorous dinosaurs in the region. One of the key challenges for paleontologists studying Arctic dinosaurs is piecing together the climate conditions of that time. The Arctic today is a cold and barren land, but during the Mesozoic era, the climate was significantly warmer and more temperate. This warmer climate allowed a variety of plant species to thrive, providing food for the herbivorous dinosaurs and, in turn, supporting a range of carnivorous species that preyed on them. Climate reconstructions based on fossil evidence and isotopic analysis of plant and animal remains suggest that the Arctic was much warmer than it is today, with temperatures possibly averaging 10 to 15 degrees higher than current Arctic temperatures during the summer months. This would have created a much more habitable environment for dinosaurs, with lush vegetation during the summer months and longer growing seasons. Scientists have also used climate models to estimate the conditions that these dinosaurs faced during the winter months. Even though the winters in the Arctic were long and dark, paleontologists believe that the average temperature likely hovered around freezing, and the daylight hours were short, with the sun dipping below the horizon for long periods of time. This would have created unique challenges for the dinosaurs, requiring them to have adapted to these extreme conditions. One of the more fascinating aspects of the fossil evidence is the discovery of bone growth patterns in some dinosaurs that suggest they were able to survive these seasonal changes. For example, the fossils of some Hadrosaurus and Edmontosaurus show evidence of slower growth rates during the winter months, which may indicate that these dinosaurs were more inactive or even hibernated during the harshest parts of the year, much like modern-day animals that live in cold climates. The ability to slow down metabolic processes would have helped conserve energy during the long, dark winters, allowing these dinosaurs to survive until the warmer months returned. As more fossils are uncovered and climate reconstructions continue to improve, our understanding of how dinosaurs adapted to the Arctic environment is evolving. These findings are not only reshaping our perception of dinosaurs, but also helping us understand how life on Earth has evolved and adapted to extreme environments throughout history. The evidence of Arctic dinosaurs is a fascinating reminder of the resilience and adaptability of life, and it paints a vivid picture of what life was like for these incredible creatures in one of the most extreme environments on Earth. Exploring dinosaurs in the Arctic has broadened our understanding of their distribution and adaptability. These discoveries show that, contrary to previous beliefs, dinosaurs didn't just live in warm regions but could also thrive in extreme cold environments. Fossils provide evidence that dinosaurs were able to survive and adapt to harsh conditions, demonstrating their remarkable ability to adapt. This also raises new questions about their behavior, social structures, and survival strategies in the harsh Arctic environment. Future studies will certainly provide valuable insights that help us understand how dinosaurs developed and survived in such extreme weather conditions. So, what do you think about these findings? Feel free to share your thoughts in the comments below the video. And don't forget to hit the like button if you found the video interesting. If you want to explore more stories about the world of dinosaurs, be sure to subscribe to the channel and turn on notifications so you won't miss any future videos. Thank you for watching.